Dear students, so welcome back to my channel, chemistry channel. So today I have come up with a new topic for class 12th, so class grade 12th chemistry, which is most important reaction, and we must know the reaction and its mechanism, how the mechanism goes, then how we can prepare the product. So generally, if you want to predict the formation of the product from the reaction, so one should know the mechanism of the reaction. And if you know the mechanism of the reaction, so the basic steps involved in the reaction before formation of the products, so then easy for us to guess the product. Then the organic chemistry becomes quite easy for you. The chemistry becomes easy the moment you understand the mechanism of the reactions and what mechanism involved in the reaction and how the product will be formed. So, and for this, so I have taken one SandMeyer reaction, which is interesting one. What I felt very interesting reaction mechanism of this SandMeyer reaction. And by using this reaction, we prepare, so halobenzene means chlorobenzene, we prepare iodobenzene, we prepare many products like chlorobenzene, iodobenzene, hydroxybenzene, so cyanobenzene, fluorobenzene, so variety of so halo arrays are we prepare by this SandMeyer reaction. So since this reaction will give multiple products, and it is necessary to discuss about this mechanism. It has great wide synthetic applications. Synthetic application it has, so we need to talk about this SandMeyer reaction. First of all, what is meant by SandMeyer reaction? So why this reaction is important? SandMeyer reaction is unique reaction where so it follows three steps before formation of the products. And we can say SandMeyer reaction based on free radical nucleophilic aromatic substitution reaction. Again, I'm stressing free radical nucleophilic substitution reaction mechanism. It involves. So mostly the raw material for this reaction is that amino benzene, aniline we can take. And the amino group present on the benzene can be converted into halobenzene. That means we replace the NH2 group by another nucleophile. We replace the NH2 group present on the benzene by another nucleophile like halogen through diazonium mechanism by three-step process. So how it is done, let us look into this reaction. The SandMeyer reaction is a chemical reaction used to synthesize aryl halides from aryl diazonium salts using copper salts reagent, copper catalyst. So why the copper catalyst is taken in this reaction as a catalyst? Let me tell about the copper oxidation states. There are two oxidation states of the copper, cuprous and the cupric. The cuprous is unstable than the cupric. So since the cuprous oxidation state, stability, instability, so we choose cuprous salts in this SandMeyer reaction to operate this reaction. So already I mentioned it is an example of radical nucleophilic aromatic substitution, and it provides a method through which one can perform unique transformation on benzene such as halogenation, cyanation, hydroxidation. Already I have mentioned. So in the first step, aminobenzene is treated with sodium nitrite plus halo acid, HCl, HBr. In the presence of cuprous chloride, then we get chlorobenzene. So this is the SandMeyer reaction. preparation of so what conditions are required, what reagents are required means sodium nitrite plus halo acid in the presence of cuprous chloride or cuprous bromide. So now let us look into the reaction conditions and the mechanism. So how the mechanism goes, let us see that mechanism. Now the reaction conditions and the mechanism, in this we take nitrous acid. So how the nitrous acid formed, when sodium nitrite react with the HCl, so we get nitrous acid. The nitrous acid typically prepared from sodium nitrite and acid by the two protonation steps. One equivalent of water is lost to form nitrosonium ion. The nitrosonium ion act as a electrophile, NO plus nitrosonium ion. When the sodium nitrite react with the 2 moles of HCl, so we get nitrous acid HNO2, which is a weak acid. So the nitrous acid which is produced will undergo deprotonation steps, which loses water molecule. Then NO plus nitrosonium ion is formed along with water molecule. So the nitrosonium ion which attack the amino group of the benzene. Here I'm mentioning nitrosonium ion which is produced, means electrophile produced from when the reaction takes place between sodium nitrate and HCl. So that nitrosonium ion attack on not on the pi electrons of the benzene, it attacks on the amino group, particularly nitrogen lone pair of electrons, where NO is connected to the nitrogen. So to form diazonium ion, we say. So proceeding through nitrosonium ion intermediate, the typical reaction conditions are as follows. Chlorination for the, so if you want to add chlorine atom to the benzene, we have to maintain the condition 50 degrees Celsius to 100 degrees Celsius temperature. So condition 36% of aqueous solution of HCl we should take. If we want to do the bromination, and we should take so HBr aqueous solution 48%, and temperature we have to maintain 50 to 100 degrees Celsius temperature. If you want to do the cyanation, we should take the potassium cyanide along with the cuprous cyanide and water. So benzene solvent we should take, temperature 0 degrees Celsius temperature we should take. Hydroxylation if you want to do, so temperature we have to maintain 25 degrees Celsius temperature, and so in this water we should take, and cupric nitrate and so cupric oxide we should take as the reaction conditions. So already I mentioned the reaction mechanism of the SandMeyer will go in 3 steps. One is generation of nitrosonium ion, and other one is and the diazonium formation, benzene diazonium formation, and third step is that very important and interesting one, that is single electron reaction method. So let us look into the step 1, generation of nitrosonium ion, how the nitrosonium ion is so formed. Now let us look into this. So how that nitrosonium ion is formed here. So look at this reaction, and in this. So in this reaction, nitrosonium ion. So this the how the nitrosonium ion is formed. So it is done based on protonation of oxygen. So generally we use acid. What acid we use? HCl. halo acid we use in this process. When halo acid is added to the sodium nitrite, so there and we can mention that so nitrous acid, once the nitrous acid is formed, so and HNO2 structure, and you can see this NO2, and in this, so oxygen has lone pair of electrons, and the lone pair of electrons is one of the lone pair is given to the proton of the halo acid. Then the proton is added to the oxygen of so nitrous acid, means HNO2, and halogen is HS, halogen bond is broken here, and the nucleophile is formed. The proton is added to this oxygen of so and NO2. So this protonation is done twice. For nitrous acid, protonation is done twice because here we can mention two things. One is nitrous acid is weaker than the halo acids. So if you compare the nitrous acid weaker one, and halo acid is a stronger one. So with respect to each other, halo acid is a stronger one, and that's why the proton is added to the nitrous acid here. And so when the proton is added to the nitrous acid twice, then we get water is eliminated from this, and we get the electrophile that is called nitrosonium ion, where the positive charge is present on the nitrogen. Since the positive charge is present on the nitrogen, it acts as an electrophile, nitrosonium ion we say. Simple mechanism in this. So the nitrous acid protonated twice by halo acid. As a result of this, when the nitrous acid react with the halo acid, so when the water molecule is removed and the electrophile is produced. Simple mechanism. So when the strong acid react with the weak acid, so automatically the weak acid behave like the base and the strong acid behave like acid. So when both react each other, the byproduct is water is produced and nitrosonium ion is formed, and Cl minus is produced here. So when nitrous acid that produced when the sodium nitrite and halo acid react, we get HNO2. HNO2 will interact with the halo acid twice so by losing water molecule, and nitrosonium ion is formed and Cl minus is formed. The produced nitrosonium ion attack on this amino benzene, means aniline benzene. So this electrophile, and interesting thing that takes place here, electrophile not attacking on the pi electrons of the benzene ring. The electrophile is attacking where, means on the lone pair of electrons present on the nitrogen. For the diazonium structure formation, you can look at this one. The electrophile is attacked to the nitrogen, then bond is formed between the two nitrogen atoms. So then since the nitrogen atom, amino nitrogen atom losing lone pair, since the positive charge is electrophilicity is formed, in order to compensate this electrophilicity, the proton present on the nitrogen atom, two protons, so by resonance process are lost, and these protons will be lost along with oxygen, then water molecule is formed. So by that means here the two protons are lost in stepwise. So stepwise, then water molecule is being formed here. So then the structure nitrosoamine structure is formed. Nitrosoamine structure is formed here, and this nitrosoamine structure loses water molecule, and so then we get the structure is after losing the water molecule, we can get diazonium structure. Diazonium structure we can get. Now look at this. After losing the water molecule H2O, see, and my water molecule is lost here, and so after losing the water molecule, simple. We can say the protons present on the nitrogen shifted to this oxygen and the water molecule is lost, then diazonium structure is formed. Diazonium structure is formed. This diazonium structure will interact with the Cl minus, it will take diazonium chloride. So this is a simple mechanism when the nitrosonium ion electrophile attack so lone pair of electrons on the NH2, then so by the resonance structure, resonance means between the nitrogen and oxygen. So what the water molecule is lost, then diazonium chloride structure is formed here. So once the diazonium chloride is formed, then it undergoes the next step, that is what we call single electron transfer method. The single electron transfer method is the unique method, free radical method we say. So the diazonium chloride, when treated with this cuprous chloride, as I mentioned, unstable, it has electron and odd electron. So when this cuprous chloride attack this azonium group and it abstract the chlorine to form cupric chloride is formed. When the cupric chloride interact with this diazonium group, then the diazonium group undergoes homolytic fission. Diazonium group undergoes homolytic fission. It undergoes so here look at this. So this diazonium group interact with the cupric chloride. The cupric chloride loses one of the halogen, and so now look at this. When this cupric chloride interact with this, when the diazonium chloride is broken homolytically, so then N2 nitrogen molecule is formed, and the free electron is left on aryl ring. On this aryl ring, the one free electron is left. When this free electron means aryl free radical interact with this cupric chloride, the cupric chloride bond breaks homolytically. Then so the one of the halogen free radical attack this benzene free radical to form chlorobenzene. Again, the cuprous chloride is formed here. This cupric chloride changes into cuprous chloride is produced here. And in this mechanism, the cuprous, which is unstable, interact with the diazonium group, and so it takes up the halogen and forms into cupric chloride. Cupric chloride is formed when this cupric chloride interact with the diazonium group, and in the presence of this cupric chloride, the bond is broken homolytically because of instability of diazonium group. Unstability of the diazonium group, then N2 molecule is formed. Then because of this free radical homolytic fission of this bond, so carbon and nitrogen and benzene get one free radical electron, and then when this free radical of benzene ring approaches cupric chloride, the cupric chloride also break up homolytically to form cuprous chloride, and the chlorobenzene is a stable product is formed. So this is the mechanism of the SandMeyer reaction, where three-step process. One is nitrosonium ion formation, and the second one is benzene diazonium formation, and the third step is single electron method. So three-step process it has, and finally we get the chlorobenzene. So based on this mechanism, so the SandMeyer reaction has wide applications, synthetic applications. Variation of SandMeyer reaction has been developed to fit multiple synthetic applications. These reactions typically proceed through the formation of aryl diazonium salt, followed by the reaction with the cuprous salts to yield substituted arene according to the scheme given below. Now, so with this, aminobenzene is converted into diazonium structure. And from this diazonium structure, so we can when the diazonium structure is treated with the cupric cyanide, we get cyanobenzene. When this diazonium chloride is treated with the cupric halide, we get the chlorobenzene and the bromobenzene. And when it is treated with diazonium chloride is treated with the potassium iodide, we get iodobenzene. And when this diazonium chloride is treated with the H2O upon heating, we get the phenol we get. So and diazonium chloride is treated so just means upon heating in the presence of tetrafluoroborate, that we get chlorobenzene, we get the Bolge-Seaman reaction, we call this is, which is very important reaction. And when diazonium chloride is treated with tetrafluoroborate, so in the presence of sodium nitrite and so cuprous salts, we get nitrobenzene, we get sodium nitrate in the presence of sodium nitrate. Since so variety of products we can prepare from the diazonium chloride when it is treated with so different products like cuprous cyanide or cupric chloride, potassium iodide, so what. So what we understand from this, the diazonium group easily can be removed because it is highly unstable above the room temperature. So the diazonium chloride formation takes place so only below 5 degrees Celsius temperature, and means 273 Kelvin to 278 Kelvin temperature only it is possible. And if you increase the temperature, rise the temperature above 5 degrees Celsius temperature, the diazonium chloride is unstable, easily decomposes. So the N2 decomposes into N2 and chlorobenzene. So this is about that so SandMeyer reaction and the formation of the so different products like cyanobenzene, chlorobenzene, iodobenzene, hydroxybenzene, chlorobenzene, nitrobenzene products we can prepare. Since it has wide application, synthetic application, this reaction is very much important. So thank you for watching my video. Thank you so much.